So hello everyone, today we are going to solve 10th question in the list, that is search and rotated sorted array. So let's read the question. The question says there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at unknown point pivot index k, or k range is in between 1 to nums dot length, such that the resulting array looks like this. And for example are given, and given an array nums after a possible rotation, an integer target return the index of target if it is in the nums, other -1 if it is not in the nums. You must write an algorithm with big O of log and runtime complexity. So let's try to understand what question says. Okay, so we are given an array. Let's take example 1, that is 4 5 6 5 6 0. Okay, 7, there is 7. So 7 0 1 2. So this is array given, and we also given a target which is equal to 0. Now we have to find a target. If there is target present in the array, then we have to return its index. Like in this case, this is the target present inside the array, so we have to return this index. Like if we do indexing 1 2 3 and 4 5 and 6, so the answer for this test case will be 4, because its zeroth index is means 0 is present at the fourth index, so we will return that index. Okay, so if there is no target present inside the array, then we are going to return -1. I hope this much is clear. Now the uh, problem also given that the array is rotated at some pivot. Like in this case, if you see, like 4 5 6 7 is sorted and this thing is sorted, so there is always going to be two parts, like one is sorted and another one sorted. But as if you consider as a whole, then the array is not sorted. Okay, so let's try to solve this. We can solve this. Firstly, we will try brute force approach, like go to every element in the array and try to compare with the target. Like if you are at the 0th index, then you try to compare with target. If it is equal, then we are going to return that index. If it is not, then go to next. It is again not equal, not equal. And if you come at index 4, then you will see that its element is equal to the target, and we will return that index. Okay, so for this approach, the time complexity of this, it will be big O of n, and space complexity will be big O of n. So let's try to code it quickly. I'm writing pseudocode for it. It's like int I equal to 0, I is less than n, and I plus plus. I will compare every element array of I to the target. If it is equal, then I'm going to return that index, that is I. If the loop ends, then I'm simply return -1, which shows there is no element present which is equal to target. So I hope this much clear to you. Let's move to optimize this, and how we are going to optimize by using binary search. Okay, so before moving to optimization, let me show you one observation here. Like in the question, it is mentioned that it is rotated at once, so this part is sorted and this part is sorted. So there is only going to be two parts that they are going to be sorted. Okay, now let's consider. I'm saying that if you go to any element in the array, let me erase this thing. If you go to any element, let's say if you consider this one, if you see its left half or you see its right half, then there is only one possible half is going to be sorted. Like in this case, if you consider this element like 6, if you see its left half, if its left half is going to be sorted, like 4 5 and 6. 6 is also included in left part, or you can also include in right part. Okay, so if you see its right half, then 6 7 0 1, this is not sorted. If you consider another, let's consider it. Let's say I'm considering this time is 7. Now if you see its left half and its right half, left half includes like 4 5 6 7, this is sorted, and right half will be 7 0 1 2, this is not sorted. Let's consider another one so that you can understand better. Okay, let's consider this one. I'm considering this one. If you see left half will be this one, and if you see its right half, right half is going to be this one, and the left half 4 5 6 7 0. So this is not a sorted. But if you see its right half, then it is sorted 0 1 2. So this is the observation you have to keep in your mind, and we will use these things to optimize, or we can use binary search in to solve this problem. Let's see how. So in binary search we will have two pointers, like one is pointing to the low uh, 0th index, which is very first element in the array, and another one is high, which is pointing to the very last element in the array. Now in binary search approach we always calculate mid, and mid is going to be low plus high divided by 2, and in this case low is 0 and high is 6. If you divide by 2, then it will give me 3. So 3 index, this one is going to be my mid. So let me mark it. This is mid. Now we know that there is only one half that is sorted, so I will find that half. Let's say this is the half, this is the left half. Okay, this is left and this is the right half. Okay, there is only one half is exists which is sorted. In this case, this half, left half, is sorted. As you can see, 4 5 6 7, this is sorted, but 7 0 1 2 is not sorted. So I'll check in 7 5 4 to 7, like 4 5 6 7 is sorted. So I'll take target, like my target is 0. I'll check, like, is target exist in between the range, like 4 and 7. The elements present inside this 4 and 7, it will be ranging 4 to 7, because it is sorted. So if I'll check, it is 0 present inside it? No, because all the elements are present inside this. It will be greater than 4 or less than 7. It might be equal to, greater than or equal to 4, or less than or equal to 7, but my target is 0, so 0 is absolutely not there. So we will move to the right part. Okay, I think this much is clear. Let me erase this thing and go to its left part. So now my array, it looks like, now let's say it will be 0. Now I'm going to right side. It means I'm moving my low pointer to mid plus 1 index. So it will be let me 0 1 and 2, and my index will be 4 5 and 6. Okay, now let me point my low is here and my high is as it is. Now I calculate mid. What will be the mid? Now this time my mid will be going to pointing to index 5. So this is my mid. Okay, now I'll search which half is sorted. This is the left half and this is the right half. Which half is sorted? This is left and this is right. Okay, as you can see, both are sorted, but you can consider anyone, like in this case 0 and 1. Now you have a target, like target equal to 0. Now you will check, is 0 present in the range 0 or 1? Is 0 lies in the range of 0 or 1? If this is the case, then we are going to move here. Like if you check, like this is also sorted, but if you check 1 and 2, so is 0 lie in the range between 1 to 2? No. So you will ultimately going to move to search space to left half. So this will be your left half. Now you will search here. Let me zoom it. Okay, now our array looks like this. Array equal to, now there is 0 and 1. Okay, now index of 0 will be 4 and index of 1 will be 5. My high is pointing to, now my low is as it is. Yes, my low is as it is. Now my high will be moved to mid plus 1. Okay, so my high is also going to point here. Okay, now if you calculate mid, then mid is also going to be here, and you have to write a condition as well, like if my array of mid equal to target, then I'm going to return, what we are going to return, its index, that is mid. So this is the whole concept. Let's code it and then we will understand better. So let's go to code part. Okay, so let me store array.size in variable n. Okay, 2 pointers 0 and high will be n minus 1. While my low is less than or equal to high, what we will do, like every time we will calculate mid, it's going to be low plus high divided by 2. Now if my array of mid is equal to target, then what we are going to return it, its index, it is mid. Now we will check which half is sorted. So we will try for left. Let me write it for left part, for left half. How we will check? Like array of low is less than or equal to array of mid. If this is the case, then the left half is sorted. Left half sorted. This is left half sorted. Okay. Now we will compare. If my target element lies array of low is greater than or equal to my target, and my target is less than or equal to array of mid. If this is the case, that means I have to move left half. How we will do? Like high equal to mid minus 1. Okay. Now if this is not the case, then we will go to right half. It will be low equal to mid plus 1. Okay. If this is not the case, if left half is not sorted, that means right half is sorted. Then we are going to check if my array of mid is greater than or equal to target. If this and my target is less than or equal to array of array of high. If this is the case, then we are going to move its right half mid plus low equal to mid plus 1, else we are going to left side, so high equal to mid minus 1. So that's it. And at last, if we don't haven't found any target element in the array, then we are going to return -1. So let's return -1. Now let's try to run this and see if it is running. Okay, we are getting compiler error. It is target where? Okay, it is target. Okay. Okay, this is accepted. Let's try to submit this. Okay, this is accepted. Thank you for watching.